Here I got two example problems straight off the review. I have got how to factor a monomial completely, and I've also got finding the GCF. So I'm going to go ahead and focus on this first problem right here. We have to factor the monomial completely, which means we have to find the prime factors between everything in here. This is the easy part right here with the variables. This is the tricky part. You may want to use a calculator if you're not too comfortable with factors, but I'm going to recommend that you familiarize yourself with your basic multiplication tables because it will come in handy later on. So the first thing that's first, we have a negative here. Anytime we're factoring out or factoring a negative number, I want you to factor out a -1 separately. So I'm just making a little factor tree here. So that leaves me with -1 times 110. So this is one of my prime factors. 110 can break up two different ways. I can make it, let's see, we have 11 times 10. 11 is a prime number. That means we cannot divide it by anything else other than 11 and 1. And then 10 we can break up into two prime factors, which is 2 and 5. So now that I have all my prime factors, I can go ahead and show you. I'm going to go ahead and multiply all these together. You multiply all these prime factors together in your calculator and you're going to get up with your original -110. So I'm going to go ahead and write that down. So -1 times 2 times 5 times 11. You don't have to put them in numerical order. That's just how I like to organize them. It would not be wrong on your test if you go ahead and put these in a different order. So here comes the easier part. We're looking at just the variables. We got to look at the exponents because when we multiply, we're adding exponents. So how many c's are we multiplying together in order to get 4? C to the fourth. It would have to be 4c. So over here we have times c times c times c times c. We're going to have to continue to read right underneath here. We have d squared, which means we're multiplying two d's together, times d times d. And then we have 3 e's, e to the third. So it's times e times e times e. So this will be our final answer in the prime factorization. So you're going to have some really weird answers on your review and on your tests. So I want you to go ahead and keep that in mind. There are extra practice problems in the book. This is the harder out of the two review questions. So I did want to get that out of the way for you so you had a better understanding. So moving on to the next question down here, we're looking for the greatest common factor between all three of these. We got to treat the numbers and the variables differently. So there's a couple of different ways to do it. I want to make it clear that we're only looking for the GCF. We're not factoring anything. We're just finding the GCF. And we can tell the difference because right here we have commas. It's giving us a list. You can't factor anything out of a list. So what I'm going to do, and I did not do it this way in class, I'm going to try it a slightly different way, is I'm going to do little tiny factor trees under each number, just so you can see the greatest common factor between them. The only numbers I can think of that go into 39 are 3 and 13. 13 is a prime number. We cannot factor it anymore. I'm going to go ahead over here. I know I want common factors, so I'm going to go ahead and divide 3 into 96 and see what happens. So when I divide 3 into 96, I'm going to get 32 as the other factor. I could continue to factor this, but here's the issue. The issue is this is my greatest common factor because 13 does not go in here. 13 cannot go in here. So 3 I can already tell is going to be my greatest common factor, but because I have a third term, I'm going to go ahead and just double check to make sure. I'm going to check in my calculator to see if 3 goes into 114. And if you do, you're going to get 38. So it does. So 3 is the greatest common factor for the numbers. Now we got to look at the variables. Here we have all the x's. So we're looking for the variable, the x, with the smallest exponent. If you don't have the smallest exponent, it's not going to divide evenly and you're going to end up with a fraction and it's going to be a big mess. So looking at the x values, here's x to the fourth, x, you know what, I'm going to go ahead and change that to x to the first because technically that's what it is. And then we have x squared. Looking at all three of these, x to the first has the smallest exponent. So I'm going to go ahead and put x here. If you want to put x to the first, that's fine. You don't have to. I don't like it, but it would not be wrong on the test. Then I'm going to go ahead and look at my y values. Looking at all my y's, because they all share y's, we got to look at the one that has the smallest exponent. And that one's going to be y squared. So that is part of my GCF, because y squared can divide evenly into all three of those variables. So y squared is a part of my GCF. So this is going to be my final answer. Remember, the question is asking, finding the GCF. We're not factoring, so make sure you read the directions very carefully. Let me know if you have any questions.